Let's move on to our third method of factoring. This method will allow us to factor polynomials that are in the form of ax squared plus bx plus c. When using this method, we are essentially going to reverse the process of FOIL, which you may recall is a method of multiplying using the first, outer, inner, and last method. Let's do a quick recap of FOIL. FOIL allows us to follow a pattern and systematically distribute one binomial through a second binomial, such as the one you see here, x plus 4 times x plus 3. As you may recall, when we perform FOIL on these two binomials, we first multiply the x term times the other x term and get a result of x squared. We then multiply x times 3 and get positive 3x. From there we multiply 4 times x and get positive 4x. And then 4 times 3 and get positive 12. To complete the process, we add the two middle terms, which are now like terms, and we get a value of 7x. Our resulting trinomial is x squared plus 7x plus 12. Now we want to be able to go in reverse. We want to go from the trinomial x squared plus 7x plus 12 to the binomial factors x plus 4 times x plus 3. So how do we do that? Recall from earlier in the process, when we multiplied x plus 3 times x plus 4, when we multiplied out those inner and outer terms, we ended up with a 3x plus a 4x in order to obtain the 7x. We had to add to get that 7x, and we had to multiply in order to get the 12. Those are the two important concepts to keep in mind as you are performing the reverse FOIL process. The other thing to keep in mind, process, 3 and 4 did both jobs. In other words, the 3 that you had here and the 4 that you had here accomplished both tasks of obtaining 7 and 12. So 3 was added with 4 to get 7, and 3 was multiplied with 4 to get 12. So the factors of 12 were added together to get 7, and they were multiplied together to get 12. So 3 and 4 did both jobs. Keeping this in mind, let's perform reverse FOIL. The first thing I always do is draw myself a set of parentheses that I can fill in my two binomial factors. The next thing I do is I ask myself what two terms were multiplied together in order to get this first term right here. And I do that first because that is the absolute easiest thing to do. X times x gave me x squared. And more often than not, that's always going to be the case. You may have p times p or q times q or a times a, but generally you're just going to have x times x to give you that x squared because it was the first term times the first term. And from there you just move forward. Once you've filled in those first terms, your next job is to figure out what's going to go in the second position of your binomials. And the way you determine that is to determine what two numbers will satisfy both jobs of multiplying to equal term C in your binomial and add to equal term B in your binomial. And while that may sound complicated, it's really not complicated at all. In this trinomial, we need to create binomials that have a product of 12 and a sum of 7. And while that sounds complicated, it's really not. And it's actually easier when you're learning if you create a systematic method of doing this. I've shown you so that you can make it organized and keep track of your numbers. We already know that 3 and 4 are our values because we saw in the previous example that x plus 3 and x plus 4 were our binomial factors. But we're still going to work this one through to see where that came from. So let's take a look at how we found that. We know that we want to use factors that have a product of 12 and a sum of 7. So how did that come about? Well, let's list the factors of 12, or at least a few of them. Let's start with 1 and 12. If we were to add 1 and 12, would that equal 7? No, that's going to equal 13. How about 2 and 6? If we add 2 and 6, will that equal 7? No, that's going to equal 8. Well, let's say we get to 3 and 4. If we add 3 and 4, those equal 7. So that tells us that 3 and 4 are the factors that we would want to use in our binomial factors. So that tells us that if we use x plus 3 times x plus 4, that would be our binomial factors of the trinomial x squared plus 7x plus 12. And we know that if we multiply that back out, x times x gives us x squared, x times 4 is 4x, 3 times x is 3x, and 3 times 4 is 12. Add these like terms, and there's my sum of 7. Let's try another one. X squared minus 8x plus 7. The first thing I like to always do is check to see if my coefficient right here is a 1. And yes, it is. The reason I check that is because this method will not work unless this is a 1. We're going to learn another method that will apply when our coefficient there is not a 1. But for now, we're just going to focus on trinomials that have a coefficient of 1. So let's see what the characteristics are that we need. Our b term is a negative 8. And our c term is a positive 7. So we need two numbers that multiply to equal 7 and add to equal negative 8. What are those going to be? So let's see. We've got to have factors of 7 with a sum of negative 8. So let's see what that's going to be. We need 1 and 7. Those are factors of 7. Are they going to add to be 8? Positive 1 times positive 7 will give me a positive 7. But if I add them together, I get positive 8. Negative 1 times negative 7 will multiply to give me positive 7, and they will add to give me negative 8. So that means the factors I need to use are negative 1 and negative 7. So that means when we want to write this, we're going to use negative 1 and negative 7 as our inner and last terms. So, writing it up, it's going to look like this. X minus 1, x minus 7. Now, if I were to test that to see how it looks, x minus 1, x minus 7, let's see if it multiplies back out. X times x gives me x squared. X minus 7 gives me negative 7x. Minus 1 times x gives me minus 1x. And I don't need to write the 1, but I will. And negative 1 times negative 7 gives me positive 7. So negative 7x times, or plus negative 1 gives me negative 8x. So x squared minus 8x plus 7. And that is what I ended up with, or started with, so that's where I want to end up as well. Let's try one more example. Let's first check if the coefficient of the x squared term is a 1. Yes, it is. 1x squared. So we're good to go there. Then let's look for our characteristics. The b term is a negative 5, and the c term is a negative 36. So we want numbers that will multiply to equal negative 36 and add to equal negative 5. So let's list our factors of negative 36 and pick the pair that adds to equal negative 5. So let's start. And you can start with any two that you like. I'm going to start with 1 and negative 36. Is there any time that I'm ever going to be able to add 1 and negative 36 to get negative 5? I don't think so. When I add those together, I get negative 35. How about 2 and negative 18? 2 times 18 is 36, but 2 times negative 18 is negative 36. Can I ever add 2 and 18 to get 5? I don't think so. When I add those, I get negative 16. So let's get numbers that are closer together because I need them to come up with a difference of negative 5. How about 6 and 6? 6 times negative 6 is a negative 36. Those are going to add to be 0. How about 9 and 4? 9 and 4 are going to have a difference of 5. If I make the 9 positive and the 4 negative, that gives me a negative 36. But if I add those, do I get a negative 5 or a positive 5? A positive 9 and a negative 4 give me a positive 5. And that's not what I need. How about if I make the 9 negative and the 4 positive? Then will I get my negative 5? If I add them? Yes. If I have a negative 9 and a positive 4, then I'll get my sum of negative 5. So those are the two factors that I need to use. I need to use a negative 9 and a positive 4. When I fill in my factors, I'm going to have x times x to give me my x squared. And I'm going to use a negative 9 and a positive 4. It doesn't matter what order you write them in. What matters is that you have the sign correct on the correct number. So I could write x plus 4 and x minus 9 if I wanted. So let's summarize. To use reverse FOIL to find binomial factors, make sure your polynomial is in the correct order, in that your x squared term is first, your x term is second, and your non-variable term is third. Your signs may be plus or minus in between. Confirm that the value of your a term, in other words, your first term right here, is 1. If it's not 1, you're going to use a different factoring method. Set up your factors, get ready to fill in your x term here in your first space, and then your other terms right here. Fill in the first two terms for each binomial factor. Remember, it's probably going to be x times x. Then find the pair of numbers that will do both jobs of multiplication and addition. These will be factors of C that have a sum of B. Set up your factor table as I did, if that helps you. And complete your binomial factors with the values that you found in step 5. Now, before we finish, x squared minus 3x minus 10. Remember, check to make sure your coefficient of the first term is 1, and then go from there. What are the characteristics that you need for B and C? Hit pause and see if you come up with the same thing I do. Okay, your B term is a negative 3, your C term is a negative 10. So we needed factors of negative 10 that add to equal negative 3. I started out with 1 and negative 10. Those are never going to add to equal negative 3. So I went down to my 2 and 5. I started out with my negative in front of my 2. But when I added those together, I got a positive 3, so I knew that couldn't work. But when I put my negative with my 5, 2 and negative 5 gave me my result of negative 3. So my factors are going to be 2 and negative 5. Factors are going to be x plus 2, x minus 5. So a positive 2 and a negative 5 give me a negative 3 when I add them. When I multiply them, they give me a negative 10. I can check that by multiplying all the way back out. So now you know how to factor using the reverse FOIL method.